So good evening, everyone. I hope you people are doing good. And I welcome you all to today's live session. We are in the week 4 live session for the course Nonlinear Vibration, NOC25 me57. And this course is being taught by Professor S.K. Dwivedi, IIT Guwahati, and I'm Rashia Aditi Ranjan, NPTEL PMRF TA from Department of Mechanical Engineering, IIT Patna. And in this live session, we will be covering questions that will be helpful for you in order to solve this week's assignment questions. And if you have any doubt, then you can ask, or we can take the doubt session in the ending as well. So, talking about the overview of what we learned in this week. So, this week was also like earlier week. This week is all about finding the solution of a nonlinear equation. So we know that the solution of a nonlinear system can be found out by two types, right? One is the numerical method, okay, wherein we discretize the system and then we find out the solution based upon the equation of motion that we have. And second one is the approximate analytical method, wherein we use the analytical methods which would help us to give the approximate solution of the nonlinear system. Okay, so these are the two main things. Now coming on to the numerical methods, we have already done many questions, already discussed how to use ODEs of MATLAB in order to solve the nonlinear systems, and everything has been done nicely. So this week was all about the approximate analytical methods. We studied about certain approximate analytical methods in the last week as well. And this week we studied more methods, like we studied about the method of multiple scale. We studied about the method of averaging. We studied about the Krylov-Bogilov method, and all these methods that are essential in order to find out the solution, right? So from these approximate analytical solution, not only we are able to get the approximate solution in a closed form, but we can also find the relation between the amplitude and frequency plots, from wherein we can obtain the jump phenomena, yeah, which are seen usually in the nonlinear system, right? So these are the things. I hope you people have already attended the classes and you know what are or what was taught. Okay, so we will be going into the questions directly. Okay, which of the following statement is correct with respect to the method of multiple scale? So coming on to what is method of multiple scale. So method of multiple scale, okay, firstly, I would like to remind that what was the method of like in which we were doing direct expansion. What were we doing? In the expansion method, what were we doing? We were writing x, which is a solution, as x naught, right? Where x naught, x1, x2, these were all function of time t, right? This was the straightforward expansion, correct? This was the straightforward expansion method, right? Now, in case of method of multiple scale, what do? We actually discretize our time also. What do? We change our time. We change our time and divide it into multiple time scales, right? We divide the time into multiple time scales depending upon the formula T n is equals to the bookkeeping parameters power n into T, okay, where n can be anything till n, okay. T is the actual time on the basis of which the equation of motion is defined, okay. This is what it is. Okay. Now, if I look into this, I can see that I will have T0 as what? T to the power 0, T1 as this, T2, this dot till Tn, where I'll have, right? These are my multiple time scales, right? One is a slowly varying scale, one is a fastly varying scale. So we have particularly divided our dynamics on the basis of multiple time scales. Okay, now after using this, the method of multiple scale, now we have since introduced the time in terms of multiple time scales. Now we are going to write x, which is a function of this, as what? Now my x naught is going to be a function of till Tn. Okay, then here also x1 is going to be a function of T1 dot till Tn plus till nth, or whichever order I want to consider for the expansion of x. Like see, for time we have considered n, but for x it is on our own hand that till what non-linearity do we want to add in our equation so as to get the accurate solution. Okay, so this is what it is. Okay, so on the basis of this we can write further that d by dt as partial differential of the function with respect to what? T naught. Okay, and likewise I can write partial differential with respect to t1 and then dt1 by dt. Likewise, so this can be further written as what? D naught plus, if you see, T1 is what? Epsilon into T. Differentiation with respect to T will give me this. So this is how the method of multiple scale works, right? Like we calculated or we took out how what is d by dt in terms of the different time scales. Likewise, we are going to find the second differential also in terms of different time scales. And then we are going to put it into the main equation and then we are going to get different equations. We are going to segregate the equations depending upon the powers of epsilon and then we are going to get 3 or 4 equations, different differential equations related to each other depending upon till what power of epsilon I'm considering in my equation. And then using those equations, I'm going to find out my approximate analytical solution. Okay, so coming on to what are the options that are given. In this method, the solution is assumed in an expanded form by the use of bookkeeping parameter. Well, this can be true, but this is perfectly true for the straightforward expansion, right? Because in case of straightforward expansion, we assume and expand the solution on the basis of the bookkeeping parameter. There is no role of the different time scales. But in case of method of multiple scale, we expand depending upon what? Depending upon the multiple time scale as well as the bookkeeping parameter. Okay, so this will not be true. Second, in this method, the coefficient of the sine and cosine are equated. No, this, if you remember, is nothing but the harmonic balance method. This is the harmonic balance method. If you remember, we did questions uh, based on the harmonic balance method, wherein what we did, we considered that the solution is of sinusoidal form, a cos omega t plus phi or a cos omega t plus b sin omega t. And then we used it and calculated the differentials, calculated x square, calculated x cube, put it into the main equation. And then on the left hand side and on the right hand side, we equated the coefficients of sines and cosines. Okay, and then equating those, we got what? We got the either we got the relation between the amplitude and frequency, or what finally we look forward of getting is the relations of A and omega on the parameters of the equation, and then we use it to get the solution. But then the harmonic balance method is only going to give me the solution for the steady state case and only if my steady state solution is of the sinusoidal form or it is of it can be written in the form of Fourier series. Okay, coming on to, so this is also incorrect for our question. Okay, this is actually what is true for the harmonic balance method. Coming on to option C, which says in this method, multiple time scale is defined. Yes, this is what it is. This is the correct answer. I repeat once again, in case of method of multiple scale, we define the time in terms of multiple time scales by which we are able to get the slow and fast dynamics, and then we are going to what? We are going to converge and we are going to uh, put together all these slow and fast dynamics, like whatever we are going to get the solution for the slow and fast dynamics using the, like, segregating the equations based on the power of epsilon and then solving it. Whatever we are going to get, we are going to then segregate it, and then that is going to give me the total dynamics of the system, which will be some of the fast dynamics, some slow dynamics, some very slow dynamics, and like that. Okay, I hope that this is clear. We'll go to second question now. Okay, so the ratio of time, this and this, all that is also okay. So firstly, this question is related to, this question is related to the method of multiple scales. It was not necessary to write it in the equation because, after seeing the question only, you people must have realized that there are different times like T naught, T4, T7, T3. So this must be related to method of multiple scale, because in all other, like, analytical form that we have studied, we have not used this multiple time scales. Okay, we have used it only in the method of multiple scale. So as I discussed earlier, also in case of method of multiple scale, what do? We define T, right? Epsilon is nothing but the bookkeeping parameter. Okay, so this is what it is. Okay, now coming on to what it is asking. Okay, Epsilon, I'll just write it is the book. Okay, so first we will try to find out A, which is nothing but T naught by T4. So for this, we first want to find out T naught, which is nothing but this. Then we have T4, which is this. So from this, we are going to get A is equals to, okay, now finding out B, we have T7 by T3. So for T7, we have nothing but this, and for T3, sorry, okay. So I have to find out that which relation is true. First is A into B. So if I do A into B, what do I get? This is what? 1. So the first option is correct. Second option is incorrect, definitely. It should actually be, epsilon to the power 0, which is going to be 1. Okay. Second one is A by B. So we have A by B as 1 by Okay, so this is also the correct option. These are the wrong options. Very simple. I don't think that this was a very tough thing. This example I took just so that the thing is clear that how we are going to relate the different time scale with the current time scale for the method of multiple scale. Okay, so yeah, we'll go to the third question. Okay, so yeah, so I have a equation and this is asking me that what is the solution. Okay, so first is that if I have a nonlinear equation and if I want to find out its solution, analytical solution. So the first thing that I look after is that till what power of epsilon should I go, for expanding the solution in order to get the approximate solution, which is closer to the real solution, right? Okay. So first approach is that I just start doing the equation by looking in the what the question is asking. Second approach is that we first wait and read the whole question along with the options available, right? So if you look into this question, you'll see that it is asking for the solution, but there is one thing that is very important to look after is that the options, in the options they have given x naught. Okay, so if you remember in state forward expansion, we used to consider x as x naught epsilon x1, likewise till whatever term we want. Okay, so this is the first term. And if you see that in the option, we have the option only for the first term, which is x naught, right? So we need not to go till to finding the approximate analytical solution. The question is just asking me the solution for x naught. Okay, so what I will do, I will use this, put it into the main equation. Also, you can see in the main equation, they have already multiplied epsilon with x square and x cube, which means that the effect of x square and x cube is very small as compared to the effect of x double dot x and the forcing term, right? It is weakly nonlinear system. We call it weakly nonlinear system. Okay, so if we want to find out x naught, what are we going to do? We will just put this equation here. Okay, so if I put it, what am I going to get? I'll have x naught double dot, likewise, plus this plus epsilon square plus cube is equal to 1.7 cos of omega t. Right? Now we are just concerned about x naught. Okay. Firstly. Secondly, if you see for this and this, x naught square and x naught cube, or whatever the term of x naught is going to come, it will already be multiplied by epsilon. So the first equation in which I'm going to segregate the coefficients multiplied with the power of epsilon to the power 0. Okay, so getting the coefficient of epsilon to the power 0. What am I going to get? I'll get x naught double dot plus x naught is equals to 1.7 cos of omega t. Clear? So this is my equation for which I have to work. You see, this is a very simple equation. It's a linear equation. Okay, so it is very important that you study the question properly. Okay, studying the question, looking into the options is very important. Don't, like during the exam, don't waste your time in finding out the whole solution, provided that you have to just find the solution for x naught. Okay, so you got the solution. So if you know that for solving such kind of equations, we get the solution x naught as nothing but the complementary function plus particular integral. Okay, so for the complementary function, what do I have to do? I will do d square plus 1 into x naught is equals to 0. So if I find the roots of this, what am I going to get? I'm going to get like d square plus 1 is equals to 0. So this will be d square is equals to minus 1. So d is equals to plus minus under root of minus 1, which is nothing plus minus iota. Correct? So based on that, I can find the complementary function. I'll add a slide. My x naught complementary function is nothing but, let us suppose some a1 e to the power it plus a1 dash e to the power minus it. So this is my complementary function. I hope this is clear. How are we getting this? This is basic mathematics, what we are doing. Okay, so this is how we find the solution for a differential equation. We find the complementary function, we find the particular integral, and we add it. So for complementary function, we take the LHS and we make the RHS is equals to 0, and then we find the root of this equation, and then those roots are essentially the eigenvalues. So using that, we can write the solution as this form. Both the roots a1 e to the power it, a1 dash e to the power minus it. Okay, if there were multiple roots, then we could write the solution like a1 e to the power at plus a2 e to the power bt plus a3 e to the power ct, likewise. Okay, now coming on to the particular integral. How are we supposed to find the particular integral? So for the particular integral, what do? We take the RHS, okay, which is actually a cost function, and then we divide it by d square plus 1, which is nothing but f. Like we have na f of d into y is equals to the RHS. For this, the particular integral is of this form, and if my RHS is sine or cos, then we replace d square by minus of omega square. If my RH is of the form sine of omega t or cos of omega t, I replace d square by minus of omega square. Okay. And if, okay, that is a different case. We will just not talk about it as of now because we will consider that in the next example. Yeah. So for a sinusoidal or cos function, the particular integral is of this form. This is how we get it. I'll just write it. Okay. If RHS is of the form sine of omega t or cos of omega t, then the pi is obtained by replacing d square by minus of omega square. Keep it very clear. D square is replaced by minus of omega square. Okay, minus is very important over here. So then in that case, my pi will be RHS, which is 1.7 cos of omega t, and I have to replace d square by minus of omega square, so I'll have 1 minus omega square. So this is my particular integral. Okay, so now if I want to write my whole solution, which is nothing but x naught of complementary function plus x naught of particular integral. It will be a1 e to the power iota t plus a1 dash e to the power minus iota t plus 1.7 cos of omega t by 1 minus omega square. Okay, so I'll look into the options. This is the correct option. Yeah, a1 e to the power minus it plus a2. We have considered a1 and a1 dash. They have considered a1 and a2. There's no problem. So a1 e to the power minus iota t plus a2 e to the power iota t plus 1.7 cos of omega t divided by 1 minus omega square. Okay, so there is one more thing that I would like to add over here. So if you must have gone through the book of nonlinear vibrations, which considers many analytical forms and is talking about the analytical methods in which we can find the solution, approximate analytical solution. You must have seen that usually they write the solution in the form of complex numbers, and then they do not write the complex conjugate values. They convert the equation in the form of complex numbers, okay? And then instead of writing their complex conjugates, they just write it plus CC, okay? Why do they do so? See, I believe that it is very important that when we are dealing with such tough equations, we keep as less number of terms as we can. Okay, so using just one part of the complex conjugates and keeping other as CC, I think it's a good way of making the equation look simpler, and dealing with it is also simple. Okay, so if I want to convert my solution in that form, if I want to convert my solution, which is nothing but A1 if I want to convert it into that form, okay, so I can write it as the sum of the complex conjugates. What will I do? So if you see the first one, sorry, we have considered is that it as a dash. So if you consider the first two terms, you will see that they are already each other's complex conjugate, isn't it? They are already each other's complex conjugate. Yeah, e to the power iota t, e to the power minus iota t, right? You know what complex conjugates are? E to the power, okay, a plus ib, a minus ib. They both are what? They both are each other's complex conjugate. Okay. So similar is applied on these two terms also. Because if you see, they both are each other's complex conjugate. Complex conjugate is nothing but we have a real part in the complex number and we have an imaginary part. So when the real part is the same and the imaginary part, one is positive and the other one is negative, they both are said to be the complex conjugates. Okay. So the first two terms are already each other's complex conjugate. Now coming on to the third term, how do I convert it? So if you know that e to the power I theta, okay, is written as what? A. Okay, we can skip the A also. Cos theta plus iota sine theta. Okay, and we have e to the power minus iota theta as cos theta minus iota sine theta. What can we do? We can add these both equations. We are going to add it. And what we are going to get? We are going to get e to the power I theta plus e to the power minus I theta is equals to nothing but cos theta plus I sine theta plus cos theta minus I sine theta. They both are going to cancel each other. And we are going to get e to the power I theta plus e to the power minus I theta is equals to twice of cos theta. Right? So in that case, we can write cos theta as e to the power I theta plus e to the power minus I theta divided by 2. This is true for all thetas. This is true for all theta. So what have we done? We have changed our variable theta. Not changed the variable, actually we have changed the variable cos theta. We have changed the term cos theta, which is actually a real uh, value, which is going to give me a real value, to sum of two complex conjugates, e to the power I theta plus e to the power minus I theta divided by 2. Correct? Similarly, you can also convert sine theta as well. How? You can write, if I'm going to, instead of adding them, if I subtract them, minus plus, what am I going to get? They both are going to cancel this time. Minus I've missed here. So these are the two equations that can be used, right? These are the two equations that can be used in order to convert any of the sinusoidal or cos function in terms of two complex conjugates. Okay, so if I use this in this, what am I going to get? I will get we have cos of omega t, so we are replacing that, and in the denominator we already have 1 minus omega square. So cos of omega t, cos of theta, we have uh, we will be using e to the power I omega t plus e to the power minus I omega t by 2. So e to the power all divided by 2, right? This can be further written as, and this will be 1.6 divided 1.7 divided by 2, 1.6, 0.85. Correct? Now we can separate these two terms. Right? Now if you see, my cos of omega t term is now a sum of two complex conjugate terms, right? So now I can segregate the iota t terms first and the minus iota t, both the terms in the last, like, okay. So what you can see, these terms are nothing but the complex conjugate of the first two terms, right? So hence we can write it as okay. I hope this is clear. So I used this because I wanted you to learn this, as this will be helpful for solving of your questions in the assignment. However, this was an easy task, finding the solution, but this change was important to discuss. So I hope that it will be helpful. Okay, I hope this is clear. So now we will go to the other question. Question number 4. Okay. The solution of equation this is, okay, there is one more thing that has to be written. Consider the value of epsilon as 0.1. Okay, consider the value of epsilon as 0.1. Okay. Again, look at the options. What did the option say? The option is saying that again we have to find nothing but the solution of x naught, right? We have to find nothing but the solution of x naught. So we don't have to go further till the higher powers of epsilon. Okay. So again we will assume x as okay till whatever term we are just concerned with x naught. Okay. Now then we will find okay we'll just put it into this equation. What is it? X naught double dot. Now see, there are two things. First, that I will just do or attempt the question as the previous one, right? Wherein what we did, we just ignored the nonlinearity term and then we used just the forcing term, right? However, if you notice for the previous question that the amplitude of the forcing function is 1.7. If you look here, the coefficient of x is 1, the coefficient of x double dot is 1, right? And x square and x cube are multiplied by epsilon, which is a bookkeeping parameter, and it is usually less than 1, very, very less than 1 to be precise. Okay. So if you look over here, that, okay, if I didn't consider the effect of x square and x cube, it is justified also because its effect as compared to the coefficient of x and x double dot, which is 1, is very less. But if I look into the forcing term, it is 1.7, which means that the effect of forcing is more than that of the x and x double dot. So we couldn't ignore it. Okay. But now there are two things. First, the amplitude of forcing is 0.1. The amplitude of forcing is 0.1, which is less than 1. Firstly, it is less than 1. Secondly, what is important is that I have already given in the question that epsilon is equal to 0.1. Right? So if you see that the effect of x cube, okay, the coefficient of x cube is 0.1 and then the coefficient of sine of omega t is also 0.1, which is nothing but equal to epsilon itself. So what I can do, I can write it as what? Epsilon sine of omega t. I can write it as epsilon sine of omega t. So I can just replace like this. So now my equation is not the same as that of the previous question. This is the thing that I saw for this question, that okay, the coefficient of sine of omega t is small as compared to 1. Okay, and then it is also given that epsilon is equal to 0.1. So the coefficient of x cube, the nonlinearity, is same as that of the forcing term. So for the first order, or segregating the value of epsilon to the power 0, we should neglect sine of omega t. And as I have replaced epsilon over here, so if I want to find out and segregate the coefficients of epsilon to the power 0 is x naught double dot plus x naught is equal to 0. This becomes our main equation, which is different from that of the previous one. In the previous case, we had a f was greater than 1. But here we have a f which is less than 1. Okay. So this becomes our main equation. So for this equation, a particular integral is definitely 0 because of 0 because RHS is equal to 0. So what is left? Just the complementary function. So my solution x naught will be nothing but the complementary function. So I have x naught double dot plus x naught is equals to 0, which can be written as d square plus 1 into x naught is equals to 0. So if I find the root, plus minus iota, right? So if I found to find out x naught, what is it going to be? It is going to be nothing but a1 e to the power iota t plus a2 e to the power minus iota t. This is my x naught. It's simple, or I can just write it as a1 to the power iota t plus cc. Yeah. So in this equation, if I see B is incorrect, D is incorrect, A is also incorrect, so C is the correct option for me. Okay, I hope that this is clear. Now coming on to question number 5. Okay, so the question number 5 says that the solution of a system given as this is assumed as x is equals to a cos omega t in order to apply method of averaging. Then x dot is given as. Okay. So this question I have taken in order to again discuss one of the main concept of the method of averaging, which says that in method of averaging, comma, the solution considered as where a and beta are slowly varying function of time. So essentially your a and beta, a is also a function of time, beta is also a function of time. So essentially then I would write the solution as okay, this is my solution. So it is asking to give x dot. X dot is easy to compute, right? What do we have to do? We have to apply d by dt of x, which is nothing but d by dt of a of t cos of omega t plus beta of t, right? So these are there is two time functions multiplied with each other, right? A of t and cos of omega t plus beta t. So differentiating the first term, we have a dash cos of omega t plus beta t. Then we have the differentiation of second function a of t into, the differentiation of cos is nothing but minus of sine omega t plus beta of t, and then it is multiplied by d by dt of omega t plus beta of t, correct? So I can further write it as, let me see first. I will take the minus outside. I will take the d by dt inside. So I'm going to have d by dt of omega t and d by dt of beta of t. So this is essentially going to give me omega plus beta dash of t. So this should be the differential of x with respect to time. However, if you remember, we use this method known as Karlov-Brigloff method, wherein we consider again that my x is of the same form a cos omega t plus beta t, but there also we consider that a and beta are slowly varying functions of time. However, if you remember, in that equation or that method, we do not consider x dot as this equation. Yeah, we actually consider x dot as minus of a omega sine of omega t plus beta. We consider this. Yeah, we actually consider this. However, a and beta are actually functions of time. However, we do not consider this. Okay, we do not consider this in the Krylov-Bigloff method. We consider this. It is assumed that x dot is this, and then that is how we actually further solve and get the solution. Okay, so I hope this is clear to you all. So the solution for this equation is going to be nothing but, okay, there is a minus now. Yeah, so this is going to be the correct answer, D. If you want, you can recollect it. I hope this is clear. There was nothing much in this question. The only concept that was required for solving this question was that the solution was given, the equation is given, and the question asked that find out x dot, so that we want to apply the method of averaging. Okay, so if you remember that the method of averaging actually considers that for the solution a cos omega t plus beta, a and beta are actually the slowly varying time varying functions. Okay, so that was the only concept that was required here. Okay, okay, coming on to question number 6. Okay, So the question says that which of the following terms in the following equation must be equal to 0 in order to get a bounded solution. So this is just another way of writing the question that which of the following terms are actually secular terms. Okay, there was a question now which said that find the secular terms, or we can write that the terms to be avoided in order to get bounded solution. Right, so if you remember that the concept of our secular term, why is it important to actually remove the secular term and those things, so I will just give a brief again. So if you remember that for a differential equation which is of the form, let us say, we have f into y is equals to, let us consider, the cos function, cos of omega t. Okay, and f is nothing but a function of the differentials. Okay, f is nothing but the function of differentials. Okay, so for this, if I want to find the particular integral, okay, for this, if I want to find the particular integral, what will I do? For particular integral, I will do cos of omega t divided by f, where d square is replaced by minus of omega square, where d square is replaced by minus of omega square. Okay, so we are going to get the solution of the particular integral. However, what if for f d square replaced by minus omega square is equal to 0, which means that the denominator is 0. If the denominator is 0, the value is going to be undefined. Okay, the particular integral is going to be undefined, because something divided by 0 is makes no sense. So if this is equal to 0, what do we do? How do we find the particular integral then? There should be a particular integral, right? So in that case, what do? We say that, okay, so if this is 0, then particular integral is going to be t into cos of omega t divided by f dash d square replaced by minus of omega square. Okay, we differentiate f. Okay, differentiation or the denominator does not concern us now. The thing that concerns us is the numerator now. Okay, my voice is not clear. Okay, is the voice clear now? Is my
Yes,
voice
ma'am.
clear now? Okay,
Yes,
thank
ma'am.
you. Okay, so this is okay. So this is the term now which is actually making things difficult. How? Because you see that my system is bounded. If you see that there is a beautiful nature of nonlinear or nonlinearity present in the system, that it makes my system bounded. Okay. But if you see over here for particular integral, if my t is going to infinity, then particular integral goes to infinity. If my t is going to infinity, then the particular integral is also going to infinity, which means that my response becomes unbounded. Okay. And the coefficients of these terms, or the terms that have such kind of a behavior, wherein the f after replacing d square by minus omega square goes to 0. The f after replacing d square by minus omega square goes to 0. Such kind of terms are known as secular terms, and these kind of terms make the system go unbounded, and hence these kind of terms should be removed in order to get a bounded solution. So these are the three ways of saying the same thing. Okay. So the question says that which of the following terms which of the terms in the following equation must be equal to 0 in order to get a bounded solution. Okay, so we have to find the secular terms, correct? Okay. So if you see here, we have d naught square x1 plus x1, which is nothing but. So if my d naught square is being replaced by minus 1, then okay, that is a secular term. So what do I have to find? I have to find the term wherein I have 1. Okay. So if you look over here, sorry, this and this is nothing but what, as I discussed earlier in the earlier question, that we have cos and sine present in the system, but then we want to make it easier to write, and hence we introduce the exponential way of writing the cos and sine functions. So similarly, we have the terms written in the form of exponentials, and then we have plus cc, which is the complex conjugates. Okay. So if you look at the first term, it is going to make the system go unbounded. It is a secular term. So the first term should not be there. So f1 should be equal to 0. Coming on to the second, which is 5i. We don't have any problem with 5i. Okay. Because the square is going to be 25 or something, and it is not going to create that much problem. So there is no problem with the second term. Up till now, the first term should be avoided. Coming on to the third term. If you see the third term, we have 2 omega minus 1. So the problem is only going to arise if my 2 omega minus 1 will be equal to 1, or my omega is going to be 1, right? Now if you see, it may happen that my omega can be 1 because omega is not the natural frequency of the system. Yeah, it is not the natural frequency of the system, so it can be anything. And we usually, when we try to find out the variation, or when we try to find out that how my system is changing depending upon the frequency, we actually change the value of omega. So there could be a conditional state wherein my omega is equal to 1, and in that case my 2 omega minus 1 will be equal to 0, and hence this will become a secular term and make the system go unbounded. Okay. Uh, when I'm saying make the system go unbounded, what I actually mean is that in the analytical solution, okay, not physically. In the analytical solution form, it will make the system go unbounded. Okay, so equal to 1. So the third term can be a secular term, or make the analytical solution of the system unbounded. Make the analytical system of the make the analytical solution of the system unbounded for only in case of the condition omega is equal to 1. Okay. So we call it nearly secular term. Okay. It conditionally makes the system unbounded. Okay, it conditionally makes the system unbounded. So therefore, looking onto the options of this questions, we have first term only. No, this is not true. First and third term only. That is also not true. So the option B is the correct option here. Right? I hope this is clear and there is no doubt in this. This was a simple concept. Okay. Simple concept based on mathematics. Anyways, our main aim is just to avoid the secular term or just to avoid my system to go to unboundedness. My system should always be bounded. Okay, so coming on to question number 7, we have a equation given and we have to use the method of averaging, which is the Krylov-Bogilov technique to find the solution. So I'm discussing this question because it will be helpful for you that see using a simple term which is like if you remember first I will tell something about this technique. It says that if my function is of this form, yeah, for this it says that my solution which is x is nothing but this wherein a dot is nothing but the integration from 0 to 2 pi of sine of phi into f, wherein f is a function of this, wherein f is a function of a cos phi and minus omega naught a sin phi. If you remember, I told earlier also that in the method of averaging we consider x as this, where a and b are slowly varying with time. So my a naught is nothing but epsilon by 2 pi omega naught integration from 0 to 2 pi sine of phi f of a cos phi and minus of omega naught a sin phi d phi. Okay, so this is what I have. Now coming on to a into b dot, which is nothing but 2 pi omega naught with a minus integration from 0 to 2 pi cos of phi f of again a cos phi d phi. Yeah. So see here we have considered a and beta as slowly varying functions of time, right? But if you see what we are doing, okay, so if you see here, despite a and beta being a function of time, we are considering x as a cos omega t plus phi. Okay, we have considered omega t plus beta and as phi. This was all discussed in the class actually. So omega t plus beta is considered as phi, and x is considered as a cos phi, and x dot is considered as a minus of a sin phi with the omega naught. Right? We are not actually considering the differentiations of a and beta with time. Right? We are not considering the differentiation of a and beta with time. So these are the two assumptions that we take despite of the fact that we consider that a and beta are actually functions of time. Okay, so these are the two equations that we have. These are the two equations that we have. From these equations, what can we do? We can find a dot and b dot. Sorry, a dot and beta dot. Right? Differentiation. We can integrate it with respect to time and get a and beta. If I know a and beta, I can put it into the main equation, which is x is equals to a cos omega t plus beta, and that is only the solution. Correct? Simple. The reason I've taken this question, because if you see over here, we have a modulus function. We have minus epsilon x into modulus of x, which means that depending on the value of x, my function is either going to be positive or it is going to be negative, right? So, firstly, what is x? X x is nothing but a cos phi. Okay, let me open the other page. So, now a is positive because it is amplitude. So, I have cos phi. So, I have to see that since here I have the integration from 0 to 2 pi. From 0 to 2 pi. So I have to look over here that my phi, cos phi is changing value how from 0 to 2 pi, positive or negative. So now I plot cos of phi, phi. What do I get? This is 0. So if you know cos of phi is 0, at 0 is 1, it comes like this and goes like this. This is 2 pi, this is pi by 2, this is 3 pi by 2. Okay, this is 1, this is minus 1. So this is how the cos function varies. Okay. Now since I'm varying my phi from 0 to 2 pi, so my x is going to be positive or negative based on that. So my x is equal to positive for phi between 0 to pi by 2, negative for phi between 3 pi by 2 and pi by 2, and again positive for phi between 3 pi by 2 and 2 pi. This is how it is. So for the modulus function, modulus of x, it is going to be x. Yeah, modulus of x is going to be x if x is greater than 0 and minus x if x is less than 0. This is how it is. Yeah, this is how it is. Okay. So in that case, my f, which is nothing but x into mod of x, how is it going to vary? It is going to be nothing but x square minus of x square pi by 2 to 3 pi by 2, and again x square for 3 pi by 2 Any doubt? I hope this is clear. This is a very easy concept. This was the main thing that needs to be done. Rest is just mathematics, pure mathematics. This was the only concept that was needed to apply. Okay. So now if I write it, the first equation. Now my omega naught, sorry, is 1. I know that. So in that case, my A dot is nothing but epsilon by 2 pi, because it is epsilon by 2 pi omega naught. Okay. Integration from 0 to 2 pi. I have sine of phi into f, which is a function d phi. Okay. Now f, I already know. I have to change, or I have to actually convert my 0 to 2 pi integration into 3 parts. 0 to pi by 2 to 3 pi by 2, and 3 pi by 2 to 2 pi. So it is going to be integration 0 to pi by 2 sine of phi, and then I have x as a cos phi. So square of it, cos square phi d phi plus pi by 2 to 3 pi by 2. There should be a minus over here. A square sine of phi cos square of phi d phi plus integration of 3 pi by 2 to 2 pi a square sine of phi cos square phi d phi. Okay, this is how it is. Now I have to apply the trigonometric identities, which says that oh, okay, these are the identities which will be required. I'll just write it over here. First, I have cos square phi written as 1 minus sine square phi. And then I have sine cube phi, which can be written as nothing but 3 sine phi by 4 minus sine 3 phi by 4. Okay, so yeah, this is how it is. So if you will apply all the integration techniques and everything, you will see that nothing but this whole integration is going to take you to the 0. This will come out to be 0. I'm not going into the whole process because this is purely integration, nothing else, which you can do. Okay, just use these two identities, convert everything into sine phi, sine 3 phi terms, and after that you can apply the integration. You will see the integration of sine phi is nothing but minus of cos phi, and when you will put the values of cos phi, like if you'll put 3 pi by 2, pi by 2, these all values into it, it is going to come out to be 0. Okay, so your a dot will be 0, which implies a is a constant value. So let a is equals to a naught. I've assumed a as a naught, where a naught is nothing but a constant value. Now I will add one more slide. Okay, now I will try to find out beta dot. Okay, so beta dot is nothing but this time I'm skipping the step. Okay, I'll just write one step. Integration here will be cos phi f d phi 0 to 2 pi. So you know f is nothing but a square cos square phi, where there is plus for 1 and minus for 1. So we will take cos a square out. So we are going to have by 2 pi into integration of cos cube phi d phi 0 to pi by 2 minus cos cube phi d phi pi by 2 to 3 pi by 2 plus cos cube phi, sorry, from 3 pi by 2 to 2 pi. Okay. Now using the identity cos 3 phi. See, this has very much like trigonometric identities and everything. So we'll just do it quickly. It's going to be 3 cos phi plus cos 3 phi by 4 with a plus. Okay. So if you're going to put this in this equation, what are you going to get? Okay. So now if you will see, okay, look at this. This is cos phi, this is cos 3 phi. Integration of cos phi is nothing but sine phi, and integration of cos 3 phi is nothing but sine of 3 phi by 3. Okay, so if I put it, I get okay, 3 sine phi, and sine of pi by 2 is 1, sine of 0 is 0. 3, 1 minus 0. Cos of pi by 3 pi by 2 is 0, and cos of 0 is 1 with a minus. So 1 by 3, 0 minus 1. This is the first term minus the second one, which is again this plus this. This is going to be nothing but 3, sorry, 3 into sine of 3 pi by 2 is minus 1, pi by 2 is minus 1. Minus 1 minus 1. Cos of 3 phi, which is 1 by 3. Sine of 3 into 3, 9 pi by 2, which is 1. And yeah. And again, sine of 3 pi by 2 minus 1 or plus 1, 1 plus 1 plus 3 pi by 2 cos 3 into sine of 2 pi 0, 3 pi by 2 minus 1 plus 1, 0 plus 1 plus 0 by 3 and sine of minus 1 by 3. Okay, so this is going to give me 3 plus 1 by 3, no, 3 minus 1 by 3, 8 by 3. And this is going to be, no, minus, not minus, it will be again plus 16 by 3 plus 8 by 3. So this is going to be my this. Now since A is nothing but A naught, which is a constant, so I can write beta naught as 4 epsilon A naught by 3 pi, right? Now if I know this beta naught by 3 pi, I can integrate it with respect to time because this is nothing but d beta by dt, right? So I can write d beta divided by 3 pi. I can integrate it, so I'm going to get beta which is nothing but the constant of integration. So I got the equation of beta, right? And A I have considered as a constant A naught, right? So now I can write the solution, which is nothing but A cos, okay, I should write it first in terms of phi because then it will be easier to understand. We can put A and beta. So this is going to be my solution. I hope this is clear, no doubt. This was easy. See, this equation I chose because of only one thing, this modulus, because it is important that we should know that how are we supposed to use the modulus function in order to solve this kind of question, right? Because since we are integrating from 0 to pi, it is important that we convert our integration into sum of multiple integrations depending upon the domain we are working on, and so that it will be easier for us to compute these values, right? So you see, by this method, we are essentially able to solve a system which has a kind of discontinuity, because if you see the plot of modulus of x, it has a discontinuity, right? It has an abrupt change at x is equals to 0, right? So with that also we are able to work with because of this kind of a method. Okay, so yeah, coming on to question number 8. Same equation we have to choose, and we have to solve it for this equation. Okay, so for this, what do I do? Again, we use the same concept. We use, right, and we have A dot is equals to right? This was the equation. Okay, I'll just recheck. What if I've written it wrong? Yes, it had a minus over here. Okay. Yeah, so this is the equation. Again, we have to replace x by for f, replace x by a cos phi and x dot by minus of omega naught a sin phi and just solve it. So we already know omega naught is equals to 1 and our f is nothing but twice of x naught. Okay, so we'll just do it quickly. Okay, I think I've done something wrong. But I'll just recheck the equation. Yeah, this I've put wrong. I have to put x dot now. Yes, minus omega naught a sin phi d phi. Minus we'll take out. Omega naught is 1. We'll take a out. We'll take 2 out. So it will be nothing but the integration of sine square phi d phi. So we can write it as 2 cancelled. We have minus of epsilon a by pi. And what we can do is we can convert sine square phi using the trigonometric identity. Sine square phi is equals to 1 minus cos 2 phi by 2. Okay, so 2 will come out and hence we are going to have integration of 1 minus cos 2 phi d phi from 0 to pi. So we will write it as we will integrate and put the values. So we have integration of d phi, which is going to be phi 0 to 2 pi minus integration of cos 2 phi sine 2 phi by 2 limit 0 to 2 pi and this will be 0. Okay, so what are we going to get? We are going to get minus of epsilon a. This is my a naught. So from this I can compute a, right? Since right? So this is going to be log of A epsilon T. A is equals to e to the power plus A naught, you can take a constant of integration. So this is going to be my expression for A, right? So if for example I have a question that okay, tell me the value of amplitude at some say t is equals to 10 seconds. So what am I going to do? I can just put t into this. If my constant of integration is given, then I'll put it. If it is not given, I can assume it to be 0. I'll put the value of t and then I can compute the value of A for that particular time instant. Okay. Coming on to the second one, which is this. Here I have epsilon by 2 pi, integration from 0 to 2 pi, A cos phi sin phi and d phi with a 2. Yeah. So 2 gone. So this is going to be epsilon A by pi integration of cos phi sin phi d phi from 0 to 2 pi. So by trigonometric identity, we can write sin phi cos phi is equals to sine of 2 phi by 2. Yeah, this is what I'm going to get. So if I integrate it, okay, so if you see cos of 2 into 2 phi, okay, I'll just write only. Okay, sorry, there should be a minus over here, minus over here, minus, minus. Cos of 4 pi minus cos of 0, which is nothing but 1 and 1. 1 minus 1, 0. So this is going to be 0. So my A into beta naught is 0. Since my A is not 0, so definitely my this is 0. So B is equals to beta naught constant with respect to time. Okay. So what we have done, we have assumed that my beta naught, since A into beta naught is 0 and A is not 0, because if you see that expression that we have considered here, A, if there is a constant of integration also, then A is not 0. And even if I consider that okay, my time is 0 or something like that, then also it will have some value. Okay, if the constant of integration is there, it can never be 0. So if my A is not 0, so my B naught is definitely 0. And if it is 0, it means that the differentiation if with respect to time is 0. It means it's a constant value that does not depend upon the time. So I consider it at this. So if my solution x is equals to plus beta, I have A as e to the power, okay, where this is nothing but phi. Okay, done. I hope there is no doubt. So taking on the last question. So my last question says that I have a forced vibration system for which this equation is given. Okay, so this equation is there. Okay, by seeing it, you can see that it is the second one, like the first one that we solved, and this is the second one. So use this to find the relation between the amplitude A and the detuning parameter sigma. Do you know what is the detuning parameter? So we define omega as omega naught plus epsilon into sigma. So we actually convert my omega in this form wherein omega naught is the natural frequency, and we say that omega varies from some value to other value wherein omega naught lies between it. Epsilon is nothing but my bookkeeping parameter, and so sigma is the detuning parameter which is used to tune the frequency. Okay. So for this equation, we want to find out the relation between amplitude A and detuning parameter sigma. Okay. So the best way to do it is, now see, for this equation, the first thing that comes in my mind is secular term, right? Uh, Till now, I guess in the class also, there has been various examples wherein it has been shared that how eliminating the secular term actually gives us the relation between the, so using this, okay, so using the concept that we want to avoid the secular term in order to get a bounded solution, we actually found out the relation between the amplitude and frequency, right? Even in I guess previous live session we discussed a question wherein we found out the relation using the harmonic balance method. Yeah, so the tuning parameter is eventually related to the frequency, so we are actually concerned about finding the relation between amplitude and frequency. So the first thing that comes in my mind is making the secular term equal to 0. So then I find out what is the secular term, what are going to be my secular terms. So if we see closely, this and this, right? Because see here, what do we have? We have, right? So if omega naught is there in RHS, it is going to make my what? It is going to make my denominator for finding out the particular integral to 0. And if it is making it to 0, it is actually a secular term. Clear and correct. Okay. So this will not do it. Only this term because it has iota omega naught t naught, and this term because it has iota omega naught t naught. With a plus, it has this. Okay. So now we want to make the coefficients of the secular term equal to 0. So what are we going to write? We are going to write twice of I omega naught a dash plus mu a plus 3 alpha a square a bar and plus half. Okay, here it is a minus, so we will consider a minus over here. Minus f into exponential of iota sigma t1 is equal to 0. Okay, so what if I assume that my a is nothing but a by 2 e to the power iota beta. Okay, so if I consider it this in this form, then I can find out a dash and I can also find out the a bar. Okay, so first I'll find out a dash, which is nothing but a dot by 2 e to the power iota beta plus a by 2 e to the power iota beta into iota beta dot. Okay, okay, instead of dash we'll just sorry dot, we'll use dash because in the question it is given as dash. Okay, so it will get converted into okay, then I will find out a square into a bar, which will be nothing but a square by 4 e to the power 2 iota beta and a bar is a by 2 e to the power minus iota beta. So this will give me a cube by 8 e to the power iota beta. Very simple. So I will just put these this one and this one into this equation, right? We'll put it in these equation, then we'll see what we are getting. Okay, so we have 2 I omega naught a dash plus mu 3 alpha a square a bar a cube by 8 e to the power iota beta minus 1 by 2 f exp of iota sigma t1 equal to 0, right? So now what can I do further? Uh, the first thing that I'm able to see is that I can take e to the power iota beta common from all. So then it will get converted into. So see, if I'm taking this common and this is already there, so what am I going to have? I'm going to have exp of iota into sigma t1 minus beta is equal to 0, right? Now what can I do? Now what can I do? First thing that I can see is that this has complex values, okay, and it is equal to 0. So this means that I can equate the coefficients of like the real terms and the imaginary terms, right, to equal to 0. Second, what I can see is that I have exp of iota into something. So I can convert it into the form cos theta plus iota sine theta, right? So first let us convert into cos theta plus iota sine theta, and we'll also take I inside. So we'll get I a dash omega naught. I square is minus 1 minus beta dash a omega naught plus 2 2 should be here, no? Plus omega naught mu into a plus 3 alpha a cube by 8 minus 1 by 2 f. Let us assume this as gamma, cos of gamma minus half f I sine of gamma is equal to 0. Easy. Now let us just take the real terms, make it to 0, and take all the complex values and make it to 0. And then we'll see what we get. So first taking the imaginary values, we have a dash omega naught. Then we have, there should be I over here also, to a and minus f by 2 sine of gamma is equals to 0. And we have minus of beta dash a omega naught plus 3 alpha a cube by 8 minus f by 2 cos of gamma is equal to 0. These are the two equations that I got when I equated the real terms and the imaginary terms equal to 0. Okay. Uh, Secondly, I considered sigma into T1 minus beta is equals to gamma. So I differentiate this. If I differentiate this with respect to T1, what am I going to get? Sigma, sorry, minus beta dash is equals to gamma dash. So what I can do, I can replace beta dash as sigma minus gamma dash. So I can use it over here, right? So what am I going to get? If I use this, what am I going to get? I'm going to get A dash omega naught A dash omega naught plus omega mu A. Okay, B dash we have to replace with sigma minus gamma dash. Yeah. So this is the final equation that I have. Okay. So what further can I do? I can take sine and cos on one side, and then I can also do is what I can also do is I can take omega naught as a denominator. No, no, no. And then I have minus of this A plus 3 alpha A cube by 8 omega naught is equals to F by 2 omega naught cos of gamma. These are my two equations, right? Now, if I talk about steady state solution, right? For steady state condition, comma, my gamma dash is equals to A dash, which is equal to 0, correct? So, do you know why I'm saying steady state? Because see, here we are considering that A and beta are actually varying, right? But for if I want to consider the variation or the dependence of the amplitude on the frequency, I will see that okay, this is only possible if I'm having a steady state oscillation, which means that my omega is also fixed, my beta is also fixed, and my amplitude is also fixed, right? Because amplitude frequency response amplitude is going to come only if I've had sinusoidal oscillation, right? So that is why we consider a steady state response. If I consider gamma dash and A dash is equals to 0, my new set of equations will become what? I'll have just mu A is equals to F sine of gamma by twice of omega naught. Okay, and the second equation is going to be 3 alpha A cube by 8 omega naught minus sigma of A is equals to cos of gamma, right? Now, what do you think is the best thing that I can do with these equations? See, I can see a sine gamma, I can see a cos gamma. I know sine square gamma plus cos square gamma is going to be nothing but 1. So what will I do? I will square on both sides. Sorry, square on both sides and add, which is going to give me, see, I have mu square mu plus a, oh sorry, mu a square plus 3 alpha 3 alpha a cube by a 8 omega naught minus sigma a square is equals to f square by twice omega naught square sine square gamma plus cos square gamma. Likewise, I have eliminated the gamma. Okay, this is going to be 1. So what am I going to get? I have the equation f square by 2 omega naught is equals to a square into mu square plus 3 alpha a square by 8 omega naught minus sigma whole square. And if you see, this is a relation, right? This is a relation which I can use. Since I want to relate, or I wanted to find out a relation between the amplitude A and the detuning parameter sigma, you can see that we have successfully done it. For different values of sigma, I can find out the values of possible values of A, right? And then I can plot it, or for different values of A, I can find the value of sigma. But usually we do the other way around. We usually change the value of the detuning parameter and then we see the variation on the amplitude. Okay, because see, we have an input and an output. So amplitude is essentially an output, but the frequency that we are providing is actually an input. So we usually work on the input in order to get the output, or how the output actually depends on the input. Okay, so I hope this is clear, and these are the only questions that I took, 9 questions for this week's live session. And if you have carefully listened to what I have taught you, what I've been trying to tell you, that how you have to solve it, you will be able to work out the assignments very easily. Okay. Uh, do you have a question, Vikas?
Yes, ma'am.
Yes, please ask.
Ma'am, can you re-explain the how you write a dash in this question?
This
Yeah,
one.
this one. Yeah.
Okay. Okay. Wait. See, I have considered a as a by 2 e to the power iota beta. Okay. So see, yeah, this is what I have considered. Okay, and I consider that my a and beta are dependent on time. A and beta are dependent on time. So if I perform the differentiation a dash, what is it going to be? See,
Okay, ma'am.
there
Okay, ma'am. It is clear now.
are you sure?
Yes, ma'am. Ma'am, I have one more doubt. In the
Yes,
previous question, uh, how you write the a dot?
this question.
Yes, ma'am.
Okay, you want to know how did we write this equation?
Ma'am, after this equation, how you write a dot?
This one. This equation you're talking about. How did this come?
Yes, yes, ma'am.
Okay, oh, see, this here,
Yes,
this
ma'am.
f. See, this is the equation of f where we have sine phi and then we have f, which is a function of a cos phi and minus omega naught a sine phi. F is what? So in generalized form, when we write it like this, okay. So this is a generalized form in which we represent these kind of equation. Okay. So whatever is multiplied by minus epsilon over here is actually my f. Okay. So here my f is nothing but twice of x naught, right? Provided
Yes, ma'am.
when I am applying this equation, it has already been provided that I have to replace x by a cos phi and I have to replace x dot by minus omega naught a sine phi. Okay. So what I have done is the equation is the same. Firstly, omega naught is 1. So I have written epsilon by 2 pi, omega naught 1. Then I have done the integration 0 to 2 pi. Everything is same. Sine phi, sine phi. Then I had to write f, provided I have to replace x by a cos phi and x dot as minus omega naught a sine phi. That is what I have done. If I replace x dot over here, what am I going to get? I'm going to get twice of omega naught sine phi a with a minus, right? That is what I have done over here. 2 into minus omega naught a sine phi d phi. That's it. That is how I'm going to get it. After that, I
Okay,
have to
ma'am.
further do the integration.
Okay, thank you.
Okay. Any further question?
No, ma'am.
Okay. So I hope everything was clear. And if you have any doubt, you can ask it in the next live session, next Tuesday. And okay, attempt your assignments well. And I'll just end the live session. Thank you very much for your cooperation.